Alright, so this is the lecture 2 for week 5. We are just going to have some more discussion on arrays. So what we already know is that arrays are just collections of the same types of variables, and to access a particular variable in the array we use its position, and that position is basically a kind of index within the array. Whatever we have done till now are essentially one dimensional arrays. Okay, so what do we mean by one dimensional arrays? We'll have a look at it. And if we wants to, if we want to visualize these arrays, one way to look at them is that they are basically variables in a line, right? I mean, this is what we can somehow, if we want to imagine an array in our memory, in our brain, this is basically how we would like to do that, right? That they are basically placed in some kind of a line. And if we go back to that example for summing up marks, what we really did was we declared an array of size 5, and these 5 variables stored marks for 5 courses, right? Now let us assume that this was just for a single student, but what if we want to store marks for more than one student, right? So how can we do that? So one way to do that would be to, of course, increase the size of the array in multiples of 5, provided that for each student we are going to store 5 marks for 5 courses. We can simply increase the size of the array. um, let us say the first 5 indices can then be given for storing marks of the first student. The next 5 could go for storing the marks of the second student, so on and so forth. But there is before we actually go towards a more a different type of array, something that we have not yet discussed. Let us just discuss something about arrays in memory, right? So there is something actually special about the variables that are part of an array. So till now we only know that whenever you create a variable, there is some memory that is allocated to you, where the value that is associated with the variable is stored. But we've never really discussed where exactly is that memory, right? It is somewhere. But when we talk about an array, all the variables that are part of a one particular array, the memory that is allocated to them is right next to each other. So they are basically in, that this is why it also makes sense to look at them like a variable line, right? So there is one linear queue of the variables where they are standing just one behind the other. The term that we use in computer science for such a kind of memory allocation is this contiguous memory allocation. This means that you have one unbroken block of memory. So so basically this memory starts at a particular address and ends at a particular address, and there is really no address in between which is allocated to any other variable. That whole block is simply dedicated to the array. So if you have for example an integer, and by the way, this is going to be true for any type of array, irrespective of what that array's data type is. It could be integer, it could be double, it could be char, it could be anything. Whenever the memory gets allocated, it is contiguous, right? So if it, for example, it is an integer array, and assuming that on your machine integer take 4 bytes of space, then basically you are allocated one chunk of 20 bytes, right? 5 cross 4, 4 cross 5, whatever it is. And similarly, if on your machine double takes up 8 bytes of space, then if you create an array of size 5 of double, then you'll be given 40 bytes in one sequence. So one of the things that this additional information about arrays provide us is that we can basically, if I have to make a compiler, and I have to somehow manage things related to generating the object code. One of the advantages of this particular mechanism that I can use is that if I simply know the starting address of the array, finding the addresses of the variables that are next in sequence, it can actually be done by some simple arithmetic, right? How we can simply do that? So for example, if I have an array like this, int arr5, and assuming again that int is taking 4 bytes of data, 4 bytes of space, and let us say that in my memory the starting address of this array is 1000, then it's very simple to calculate the address for the other indices, right? So for example, arr1 will be at 4 bytes from the starting address, arr2 will be at 8 bytes from the starting address, arr3 will be at 12 bytes from starting address, so on and so forth, right? So basically, if you know the size of the data type which is associated with this array, and if you know the initial the starting address of the array, you can then find addresses within the memory for all the variables, right? So this is something that we had not discussed before, that uh, with different variables we had different names. So maybe there was some way to recognize what memory location do they point to, but with an array we just have one name, right? So for example, arr is the name, and then we have these indices. So this is basically how I can reach those individual variables. If I have the initial or starting address of the array, and I have an index, I can go to any particular memory location within the array. So if I just try to generalize it, essentially the address of arri, the ith member of starting from 0, of course, the ith member of the array is basically the starting address of arr, and then I into size of the single element of arr. So now you can probably understand what is the advantage of starting arrays from 0 instead of 1, right? So the first variable is at arr 0, so basically in this formula I becomes 0, so then that becomes the starting address of the array. And then the second one, for second one you just want to multiply it by by 1. This is the idea. So this is why we start this is a good motivation to start indexing the array from 0 instead of 1. So let us go back to that issue of storing students marks. I said that there is one more way of doing that instead of just simply keep on adding to the size of the array. And this is what I discussed before, that we can store marks for n students by creating an array of size n cross 5 elements. So if one student requires 5 elements to store marks, we simply are going to multiply it by n. And then we can have some kind of a convention which says that the marks of the first student is stored in indices 0 to 4, the second one is stored in indices 5 to 9, and so on and so forth. Basically the ith student, for the ith student the marks are stored in there is we can derive a simple formula that it is basically I into 5 to I into 5 plus 4. Now there is one more way to do this with the help of multi-dimensional arrays. So essentially what I can do is I can add a dimension to the array. So whatever we have done till now, they were, as I said, they were one-dimensional arrays. What we did was we did something like this. If we wanted to create an array, we simply wrote marks and then square brackets and then the size of the array. But what we can also do is, instead of just giving one pair of square brackets, we can actually have something like this. I can have two, and I can actually have more than two as well. But usually, in most cases, you will probably not require anything more than two. Okay, so most of the cases that you'll come across in programming, they'll probably be, it'll probably be fine to simply have a two-dimensional array. Sometimes, I probably have used a three-dimensional array, but nothing more than that. But the idea is that instead of declaring a variable of declaring an array like this, I can declare it like this. So essentially what this means is, now again the total amount of memory that I need is exactly the same, right? It is basically for this n cross 5 elements. Sorry, it is this, yeah, this is n into 5, yeah, it's the same thing. So the total amount of memory I need is basically n into 5 elements for, and so n into 5 into size of the data type. but but the only way that it is making it easier for me is that I now have another dimension to visualize my array, right? So one pair of brackets essentially represent one dimension, and so basically a two-dimensional array, similar to a one-dimensional array which was like variables in a line. Now when you have two dimensions, you can simply start looking at them as variables being arranged in rows and columns, right? So this is a simple idea that I'm trying to show you, that this is a one-dimensional array, and these are the indices. They start from 0 and go up to 14. So this is basically an array of size 15. Essentially, this is you know marks for three students, right? So 0 to 4 are storing think about it like this, that 0 to 4 are storing marks for the first student, 5 to 9 are storing marks for the second student, and 10 to 14 are storing marks for the third student. But you can understand that this is a little more difficult to imagine and explain to someone. On the other hand, this is much more easier, right? So essentially what I'm saying is that now I have two set of indices. So there is, this is the first index. In some ways this is representing a row, okay? And essentially what I'm trying to say is the first index represents the student number. So this is for student number 0, this is for student number 1, this is for student number 2. So I have three students, so I have three indices here. And then this is the second dimension, where I am basically saying this is for course 0, this is for course 1, this is for course 2, 3 and 4, right? Now this is much more natural, right? Because even though I can simply represent this data in this way as well, but this seems more natural, right? So this is how we usually interpret data. Again, let me be very let me remind you that when it gets stored inside the memory, it is basically the same thing, right? I mean, they are just contiguous memory locations like this. But if you use a two-dimensional array, we can use two different indices, okay? The final memory the final calculation of the address of a particular variable, again you can do that with the help of a similar formula, right? So if I tell you the starting address of the array, and I tell you the sizes, right? So in dimension 1 what is the size, in dimension 2 what is the size. Usually I don't need the I usually need this one but not this one. But anyhow, if I tell you the sizes of the arrays in two different directions, I can easily calculate with the help of some simple arithmetic the same thing, right? So whatever arithmetic I was able to do here, I can do the same arithmetic in this representation as well. So now, usually, we have seen that in order to access elements of an array, we saw that for loop is a very good loop, because it you can simply say start from 0 and go up to size -1, and you can simply write it like I equal to 0 and then I less than size, and this will run for size number of times. Similarly, for two-dimensional arrays, usually we use nested loops. So essentially, I now have two indices I and j, and I the outer loop runs for the number of first index. So this is my first index. So here, this is 3. So m equals 3, and n equals 5. I have 5 elements on in the second dimension. So this is a way to actually write a nested loop. I start from I equal to 0, and this goes up to m minus 1, and the inner loop starts from j equal to 0, it goes up to j less than n. And now if I want to access a particular element, this is how I do that: arr and then I and j. So this is one way to, again, this is not necessary that it is not necessary that you use a nested loop like this to access two-dimensional arrays, but yeah, this is the most common way to do it. Now that same marks summer program, where we are trying to now sum marks for multiple students. This is these are two parallel versions of the same program. This one is using a one-dimensional array of size n cross 5, and this one is basically using a two-dimensional array. And then this is n cross 5, as in it essentially has n in one dimension and 5 in the second dimension. This is what you can see here. This is n and this is 5, whereas here it is just n into 5. So this is the difference I'm trying to say. And this is actually the piece of code. You can just see that there is a nested loop here in the two-dimensional array part. And here I'm just using a single loop which runs from 0 to n into 5 minus 1. And here this one starts from 0 to this one goes from 0 to n minus 1, and this one goes from 0 to 4. So just convince yourself that these two pieces of code, by the way, these two examples are already there in Google Drive, so you can go and check them out. But do convince yourself that these two code fragments are equivalent. So the idea is that I can actually do the same thing using one-dimensional arrays as well. It's just that if I use two-dimensional arrays, it provides a bit more convenience to me. It is easier for me to visualize the data with respect to the real world. Okay, so this is your homework. You can have a look at it. We are going to discuss this in the class on Tuesday. Thank you.